For nearly 3 hours, a British submarine followed a sound it could not afford to lose. There was no enemy silhouette on the horizon, no wake cutting across the surface, no column of smoke revealing a distant engine. Somewhere beneath the cold water off the coast of German-occupied Norway, another submarine was moving slowly and unpredictably, changing direction as though its commander already suspected that something was hunting him. Lieutenant James Jimmy Launders, commanding HMS Venturer, faced a problem no submarine officer had ever solved in combat. He was not trying to strike a ship traveling across the surface. His target could turn left or right, accelerate, slow down, rise or dive. It could disappear into deeper water without warning. The British hydrophone operators could hear machinery and propellers, but sound alone could not provide a perfect position. Launders would have to predict where an invisible submarine would be several minutes into the future and send his torpedoes toward points that, at the moment of firing, contained nothing but seawater. If his calculations were wrong, the German boat would escape. It could warn other U-boats that a British submarine was waiting near the Norwegian coast. It might even turn and attack Venturer. If the calculations were correct, Launders and his crew would achieve something that had never happened before and has never been repeated since. The target was U-864, a German Type 9D2 long-range submarine commanded by Korvettenkapitän Ralf-Reimar Wolfram. But this was not an ordinary combat patrol. The U-boat was carrying a secret cargo intended to help Japan continue the war. The mission was known as Operation Caesar. By the final months of 1944, Germany and Japan remained allies, but they were separated by enormous distances and by oceans increasingly controlled by the Allies. Germany possessed weapons technology and industrial knowledge that Japan wanted. Japan controlled access to strategic materials that Germany needed. On paper, exchanging these resources made sense. In reality, transporting them had become extraordinarily dangerous. As Allied naval and air power expanded, surface blockade runners became increasingly vulnerable. Germany and Japan therefore used long-range submarines to maintain a narrow technological connection across a collapsing Axis world, carrying raw materials, specialists, technical drawings, and samples of advanced weapons. U-864 was assigned one of the most ambitious of these passages. Its planned route would take it from Germany, around the North Atlantic and the Cape of Good Hope, across the Indian Ocean, and eventually toward Japanese-controlled territory. It was a journey of thousands of miles through waters patrolled by Allied ships and aircraft. Inside the submarine were components associated with advanced German aviation and weapons development. According to the Royal Navy's historical account, the cargo included parts for Messerschmitt jet engines and equipment connected to the guidance of V-2 rockets. U-864 also carried a large quantity of metallic mercury. Official Norwegian assessments use approximately 67 metric tons as the historical starting estimate, although the exact amount originally loaded is not known with certainty. The mercury was believed to have been stored in steel containers within the keel. It had military applications, including use in initiating devices for bombs, shells, and torpedoes. This made U-864 more than a submarine moving from one base to another. It was a submerged transport carrying technology and material that Germany hoped could strengthen Japanese production at a moment when both nations were being pushed back. The cargo alone could not have reversed the war, but a jet engine component, a guidance mechanism, or a technical specialist could still help create weapons that would cost Allied lives. Operation Caesar therefore had to be stopped if the opportunity appeared. The German mission, however, began with a sequence of delays. U-864 suffered damage while transiting the Kiel Canal and had to seek repairs in German-occupied Norway. The submarine reached Bergen, where enormous concrete pens had been constructed to protect U-boats from conventional air attack. An Allied air raid struck the area and delayed work on U-864. The mission slipped further behind schedule. Time was running out for Germany, and every additional day increased the possibility that Operation Caesar would never reach Japan. More importantly, the mission was no longer completely secret. British intelligence had intercepted and deciphered German naval communications connected with U-864's movements. The details available to the British did not remove every uncertainty, but they transformed the search. Instead of sending ships and aircraft to examine the entire North Atlantic, the Royal Navy could place a submarine near the route the German boat would have to use when leaving the Norwegian coast. The weapon chosen to stop a submarine was another submarine. HMS Venturer belonged to the Royal Navy's V-class and operated with the 9th Submarine Flotilla in northern waters. Its crew worked in a confined steel hull where discipline mattered as much as machinery. An unnecessary pump or careless movement could create a sound that traveled through the water. Launders was young, but he was not inexperienced. Venturer had already sunk German vessels, including the U-boat U-771 off Norway in November 1944. That earlier submarine had been caught on the surface. The mission awaiting Venturer near Fedje would be fundamentally different. The Royal Navy ordered Launders to patrol west of Fedje among rocky islands and narrow coastal routes. Beneath the surface, local conditions could complicate the way sound traveled. The ocean did not provide a clean map. It provided fragments. Venturer took position and listened. Using active sonar might have provided information, but it could also announce the British submarine's presence. Launders depended heavily on passive detection. The hydrophone operators searched the underwater soundscape for patterns that did not belong: the beat of propellers, the rhythm of engines, and the mechanical noises transmitted through a submerged hull. For the men wearing headphones inside Venturer, the enemy did not initially appear as a ship. It appeared as sound. On February 9, 1945, the hydrophones detected U-864 off Fedje, approximately 30 miles north of Bergen. The moment of contact did not produce an immediate attack. Locating a noise was not the same as possessing a reliable firing solution, and U-864 was not presenting itself as an easy target. The German submarine remained submerged. A hydrophone bearing could indicate the direction from which a sound arrived, but it did not automatically reveal exact range, course, or depth. Launders had to combine repeated observations with estimates of speed and movement. Each new bearing modified the picture. Each German turn threatened to make the previous estimate obsolete. Then the target made the problem even harder. U-864 followed an irregular zigzag course. Whether Wolfram had detected something unusual or was simply applying precautions in dangerous waters, the result was the same. The submarine refused to maintain the steady movement on which a conventional torpedo calculation depended. Venturer began to follow. The British submarine had to remain close enough to preserve contact but quiet enough to avoid being detected. If Launders lost the sound, U-864 might vanish into the Atlantic. If he approached too aggressively, the German hydrophone operators might hear Venturer and give Wolfram time to reverse the hunt. Minutes became an hour, then another. For approximately 3 hours, Launders tracked the German submarine through hydrophone information and limited observations. The pursuit demanded patience from every man aboard. Machinery had to be controlled. Orders had to be passed calmly. The crew could not see the target whose movement governed every decision around them. Launders could not know precisely what Wolfram understood. He could only study the German movements. Every observation created another point on a developing track. Every change in bearing suggested another turn. Gradually, Launders and his officers attempted to identify a pattern within the zigzagging course. They were not merely calculating where U-864 was. A torpedo required time to cross the distance. They needed to determine where the German submarine might be when each weapon arrived. This was the central difficulty of the attack. Traditional submarine torpedo calculations were largely concerned with a target moving across the surface. Its course could be plotted on a plane. Even then, the commander had to estimate range, speed, angle, and the travel time of the torpedo. A small error could become a wide miss after several minutes. Against U-864, there was another dimension. The target could change depth as well as direction. Launders had incomplete information about a vessel whose movement could not be continuously observed. The British torpedoes could not receive corrections after launch. Once they left Venturer, they would continue along the courses set for them. Modern cinematic images often show a torpedo turning repeatedly as it follows a target. That was not the weapon available to Launders. The Royal Navy describes Venturer's torpedoes as fire and forget. There would be no wire connecting them to the submarine, no digital seeker updating the solution, and no second attempt once the German crew heard them approaching. Launders had 4 torpedoes ready. Firing all 4 toward one predicted point would increase the violence of a successful strike, but it would also make them vulnerable to the same error. If the prediction was wrong, all 4 could miss together. Launders instead constructed a spread covering different possible positions in U-864's future movement. The weapons would be launched separately toward different points and at intervals of 17.5 seconds. Each torpedo represented a prediction. Together, they formed a pattern. The decision carried risk. Launching would reveal that Venturer was nearby. If the attack failed, U-864 was an armed submarine capable of fighting back. Norwegian government assessments identify the Type 9D2's weapons as including 53.3 centimeter torpedoes, along with deck and anti-aircraft guns for surface use. Beneath the water, the torpedoes were what mattered. Launders was about to surrender surprise and place his own crew inside the same underwater battlefield. After hours of listening and calculation, the firing order was given. The first torpedo left Venturer. Its launch created a mechanical sequence that could be felt and heard inside the British boat. Compressed air expelled the weapon, and its propellers began driving it through the water toward a point ahead of the German submarine. For those aboard U-864, the approaching sound would have transformed uncertainty into immediate danger. Somewhere nearby, an enemy submarine had already completed its calculations and fired. 17.5 seconds after the first launch, Venturer fired the second torpedo, then the third, then the fourth. The weapons did not follow one identical line. They moved toward different positions across the German submarine's possible route. The intervals between them extended the trap through time as well as space. U-864 reacted. Wolfram ordered evasive action. The German submarine altered its movement in an attempt to escape the approaching weapons. The first torpedo missed. The second also passed without striking. Then the third missed. For a moment, the German maneuvers appeared to have defeated the attack. 3 weapons had entered the water and 3 had failed to hit. If Launders had fired a conventional group along the same solution, U-864 might already have been escaping toward the Atlantic. But the 4 torpedoes had not been 4 identical attempts. The fourth was still approaching along the last line of the calculated spread. As U-864 maneuvered away from the first 3, it crossed the path of the final weapon. The torpedo struck. The explosion tore the German submarine into 2 principal sections. The mission, the technology intended for Japan, and everyone aboard descended to the seabed west of Fedje. Inside Venturer, the British crew could not watch the impact. Confirmation came through sound, the underwater detonation, and the noises that followed. After almost 3 hours of incomplete bearings, restrained movement, and calculations made against an unseen opponent, the encounter ended in seconds. On February 9, 1945, HMS Venturer became the first and remains the only submarine known to have sunk another submarine while both vessels were fully submerged. The achievement was not simply that Venturer detected U-864 first. Launders had allowed the tactical picture to develop. He resisted the pressure to fire before he understood enough of the German movement. When he finally attacked, he did not direct every weapon at where the target appeared to be. He created several possible futures and sent a torpedo into each of them. The first 3 forced U-864 to react. The fourth occupied the route through which the German submarine attempted to escape. Operation Caesar ended only a few nautical miles from the Norwegian coast. The advanced components and military materials never reached Japan. The loss could not determine the outcome of a war already moving decisively against the Axis, but it closed one more route through which Germany had tried to transfer its technology before collapse. The Royal Navy continues to regard the attack as a classic example of gaining the optimum firing position and thinking differently under conditions of uncertainty. Modern submarines possess sensors, computers, and guided weapons Launders could not have imagined. Yet the principles behind the action remain recognizable: preserve contact, control noise, understand the opponent's options, and position weapons where evasive action is likely to carry the target. The story also continued beneath the sea. For decades, the precise location of U-864 remained uncertain. In 2003, the wreck was identified approximately 2 nautical miles west of Fedje at a depth of about 160 meters. Its 2 major sections lay separated on the seabed, surrounded by wreckage and contaminated sediment. The discovery confirmed that the cargo lost in 1945 had not become harmless with time. Mercury containers had been carried in or around the keel compartment. Some of the material spread into the sediment around the wreck and began leaking into the surrounding marine environment. Norwegian authorities initiated extensive surveys and considered several possible responses, covering the wreck and contaminated seabed, attempting to remove the mercury before covering the site, or raising wreck sections and cargo. None of these choices is simple. The amount of mercury remaining and the condition of its containers are uncertain. The wreck may still contain torpedoes and other ammunition. Removing the pollution could disturb contaminated sediment or expose recovery crews to unexploded weapons. The submarine that failed to carry its cargo to Japan therefore became an environmental and engineering problem for Norway generations later. Its wreck is simultaneously a war grave, a contaminated site, and physical evidence of one of the most unusual naval actions in history. HMS Venturer survived the war. It was transferred to the Royal Norwegian Navy in 1946. Jimmy Launders continued his service and eventually retired with the rank of captain. He died in 1988, but the tactical legacy of his attack remained part of Royal Navy submarine history. The name Venturer has now returned as the lead ship of the Royal Navy's new Inspiration-class frigates. The modern vessel is not a submarine, but its name deliberately recalls a small wartime boat and a crew that solved a problem without modern guidance systems or continuous tracking. The battle west of Fedje involved no visible exchange of gunfire. There were no battleships silhouetted against the horizon and no aircraft diving through clouds of anti-aircraft fire. For most of the engagement, neither crew could see the other. There was only cold water, machinery heard through hydrophones, fragments of information, and 4 torpedoes moving toward 4 different points in the darkness. U-864 avoided the first, then the second, then the third. But Jimmy Launders had not fired only at where the German submarine was. He had fired at where it might turn, where it might dive, and where it would try to escape. The 4th torpedo was already waiting. Subscribe to DWWA and join us as we uncover more extraordinary stories of naval warfare, legendary vessels, and the men whose courage and decisions changed history beneath the waves.